Okay. There you go. Thank you. Assalamu alaikum. We are going to start. Uh, First of all, is the sound is clear or not? And can you see the slide linear system or algebraic equations? Yes, sir. Can you see the PDF linear system of algebraic equations? Yes, sir. Okay. Yes, sir. So today we will study on technique Gauss elimination method to solve the linear equations. So why we will study linear equations? Why we need to solve that equation? From background of electrical engineering, we all are familiar with this circuit, this type of circuit. If we write the KVL of this circuit or we will apply any electrical law here, then mostly we will get some linear equation from this. And if we solve this equation, then we can calculate the current, voltage, etc. of the circuit. So this is the very simple application of electrical engineering with linear system. That is why we will study today Gauss elimination method to solve the linear equations. Okay. Can you see now? 9.1 article, system of linear equations, Gaussian elimination. Can you see this? Yes, sir. Yes, sir, we can see. Okay, thank you. So our focus in this section is linear equations in several variables. We don't know how many variables. So linear equation, how can we understand this system is linear? If there are two unknown and two equation, then easily, or three unknown, three equation like this, we can say this is linear system. A solution to a system of linear equation consists of a variable of is variable such that when we substitute these values, every equation becomes a true statement. That means, say this is the equation, first one, 2x minus 5y plus 3z equal to minus 4. When it will be linear, if we multiply with, say, we are multiplying with any variable, say a, both side, right side and left side. If we multiply 2xa minus 25y plus 3za equal to minus 4a, then the statement will be true as if it was true before multiplication. So this is linear system. So how we will apply to solve this equation? The technique named Gauss elimination method. So before going to that, we should know the equation, a system of three linear three equations in variable, say x, y, z, is said to be in Euclidean from if it can be written as like this. So here in Gauss elimination method, our main target will be convert our three linear equations like this way. A1x plus A2y plus A3z equal to D1. B2y plus B3z equal to D3. C3z equal to D3. We know how we can convert this equation by this way. So elementary operation and Gaussian elimination, the systematic elimination of variables to change a system of linear equations into an equivalent system is Euclidean form from which we can read the solution is called Gaussian elimination in honor of the name of the scientist, one of the most brilliant mathematicians. So how can we make our system like Euclidean system? Is we can convert our equation to Euclidean equations. There may be three or more process. Very familiar process are interchange two equations. That means we have two equation E1, E2. We can change or interchange E2 and E3. Another way, multiply by a non-zero constant. Our E3 equation will multiply with 4 to both sides, left side and right side. That means 4E3 will be nil 3. This can be a process. First one was we will interchange two equation. Second one multiply by a non-zero constant. And third one add a multiple of one equation to another equation. It's also possible. Say 4E2 plus E3 equal to E3. That means new E3. That means E3 will be replaced by 4E2 plus E3. It can also be possible. Why we will do this? Our target is to make our equation, three linear equation like this. Then very easily, what will happen if we can get this equation? From equation 3, we can very easily determine the value of z. Z equal to d3 by c3. When we will get the value of z, then we will put here z. Then we can calculate y from this equation. So when we will get z and y, very easily we can calculate x from this equation. So our target will be determine the value x, y, and z. So first we will determine z, then y, and then x. This is our target. This process is called Gauss elimination method. So if we go for an example, Euclidean form, reduce the following system to Euclidean form and then find a solution. Sometime the question will be like this. First, form the Echelon form and then find a solution using Gauss elimination method. So if this is the equation, how can we can solve this equation by using our calculator? Very easily we can do three equation and three unknown. So we can solve, but using Gauss elimination method, how can we solve this problem? This is our target in this class. So say this is three equation. So we can identify this E1, E2, and E3. So how can we apply our three concept? First of all, first one is interchange method, or multiply with a non-zero constant, or multiply and interchange, or plus or minus. We can do in many ways. So here, if we check 2x minus 5y plus 3z equal to minus 4, we just change. Why we change this? We have some other target to do in next process, in next stage. So first we just change. We can change, no problem, because this is linear equation. We can do anything, multiplication or interchange, everything. So just interchange E1 and equation E1 and E2. So then what can we do? Minus 2 E1 plus E2 equal to. That means our this equation, we want to convert this equation with something other. What we did? Minus 2 E1 plus E2. E2 that we have, and minus 2 E1. That means first we have to multiply this equation. Minus 2 E1. That means 2x minus 2x. Then 4y. Then 6z, or like this. If after this, if we do this action plus, if we add this with E2, then this equation will be like this. Our equation 1 is as usual. We didn't do anything. And equation 3 also we changed. Why we are doing this? Very simply, if we will check here, if we check all these coefficient, we need to make this coefficient 0. This coefficient, this coefficient, this coefficient, this coefficient. Then we will get this equation. It's an equation. So if we do this multiplication and addition, that means 3.1 plus E3, then we can write this equation, equation 3. Please.
Hey,
Oh,
job.
so this, if we can understand these three questions, first one, second, and three. First one is intact, and we already changed equation 2 and 3. Now, very easily we can apply this rule. Minus 2E2 plus E3 is equal to, then we will get this equation. Also this equation. So from this equation, we can say z equal to minus 1. If z is equal to minus 1, then we can put here, that means minus y minus 9 is equal to minus 10. Then please.
The second delay for
Sir, you can mute everyone from the settings. Please mute everyone, sir.
Okay. So this is the solution. What can we do to solve this problem? This is called Gauss elimination method. That means we are eliminating some term. this is one process that we can do. Again, we can do by other way, matrix form. If we convert our target equation to matrix form, then we can apply our three concept. That means interchange, zero term, or multiply,
Assalamualaikum.
addition, subtraction.
সামিন একটু মাইকটা অফ করে কথা বলো।
So most probably, I believe, you know, if this is three equation, from this three equation, we can write matrix form. We can convert this equation by this way. Very simply, we can do. We can separate the coefficient to form a matrix, augmented matrix, and then we can apply our Gauss elimination technique to eliminate the pivots. So how can we do this? We again will check. I am coming to limitations, but before this here. First, I request you all try to understand. If you understand now, I think you don't need to practice anymore. It will be. So these three equations, let's again we'll solve by using matrix concept. This is x1 plus 10x2 minus x3 equal to 3. We have these three equations using the Gauss elimination with partial pivoting. How can we solve this problem? So we can write this 1, 1, 10 minus 1, this 3. 2, 3, 27. 10 minus 1, 2, 4. We can. So now our target is to make this one 0, this one 0. If we can do this, this one will be automatically 0. That means this position. If we say this is A11, if this is A21, 31, so A21 and 31 should be 0. It will be our target. How can we make this coefficient 0? Then we can apply our concept, interchange or addition or subtraction like this. Say here, first R1 interchanged with R3. And then R2 minus R1 by 5, R3 minus R1 by 10. If we do this, like say, this is our target, is to make first this to 0. And then our target will be to convert 0, 10.1. How can we do this? This will be our target. This is a linear system. If we do anything, the result will be same. That means the statement will be true as if it was true to do anything intact, as if the intact equation. So if we do this R1 and R3, and then this is 10 minus 1, 2. 10 minus 1, 2. The equation 2 is intact. 2, 3, 27. Same. But we just change 1, 10 minus 1 and 3. The first one and third one. First this one and this one. We just interchanged this. If we interchange, then our next target will be R2 minus R1 by 5. R2 minus R1 by 5 and R3 minus R1 by 10. How can we do this? Or how can we convert this equation? How can we get this equation? Say first one 10 minus 1, 2, 4. This is as usual. But these two become 0. How can we do this? So we have 2 here. If we do minus R1 by 5, R1 is 10, R1 by 5 is that means 2, and 2 minus 2 will be 0. Here we can do other thing also. Please remember here, our target is to make this 0. That means these two position A2 on, we can say, we will make this 0. We have other way also. If we do this, that means R2 minus 2R3. It will convert to 0. It's also possible. So anyway, we can do this, but our target is to make this position 0. This position is 0 and other is as usual calculation. That means this 3 we have and minus 1 by 5. Minus plus. So 1 by 5, it will be addition with 3. That means 3 plus 1 by 5 means 2. That is 3.2. This is as 19.6 is also same if we calculate this. And then R3 minus R1 by 10. R3 is, it was R3, that means 1. R1 by 10, it was 10. 10 by 10. R1 is 10. 10 by 10, that means 1. So 1 minus 1 is 0. This is 0. So we just we are targeting to make our equation so Euclidean equation, like that means our target like this. We have many things. There will be our equation. So this on this, it should be 0. Something will be here. It will be 0. It will be 0, and it will be something. Now, if this is our target, then anyhow, again I am just I am mentioning here, this is only the way to make this term 0. You can do this. That means this 2 minus 2. That means if we do say R2 minus 2 R3, then it will be also 0. It's also possible. So you can just think for a few seconds and then apply any method to make this term 0. So if we can apply this, then we'll get this equation. From this equation, again, our target is to make this. So we have this 2, 0, 0. Then our target is to make this 0, 10.1. How can we do this? And to do this, we can again interchange R2 and R3. Simply we can get this. And when we will get this, we have 3.2. From 3.2, how can we get this term 0? That means we have to convert other equation with this. We can multiply with this equation 1 with 3.2, then it will be 0. But remember that R is these two, of course, it should be intact. We get this 2, 0. We should not touch this. We will just focus on this point to make this 0. We can do this R3 minus 3 by 2 by 10.1. Then R3 we have 3.2. If we subtract 3 by 2 by 10, then it will be also 3.2 into R2. So then this term will be 0. When we will get this 0, 0. So if we again multiply, if we convert this metric form to equation again, we can very easily, we can say 19.98020 into Z, sorry, X3 into X3 equal to 5.37. From here, we can determine X3. X3 is equal to this divided by this. So if we get X2, we can put with equation 2 here 10.1 X2 minus 1.2 X3 equal to 26, 2.6. So 10.1 X2, we don't know X2, but minus 1.2 into X3, we have this value. That means if we calculate this, then we can very easily determine the value of X2. And last one, from equation 1 is 10x1 minus x2 plus 2x3 equal to 4. So we have value of x2, x3. So only one is unknown, that one is x1. So we can calculate x. So this is the three value of x1, x2, x3. Again, why we are calling this Gauss elimination method? We are trying to eliminate the coefficient of matrix step by step, and we are converting our equation to a Cillian equation. At last, we are calculating our target value. So again, if you want to practice, again you will get this. We have three equations. So before this, before going to solve another problem, if you have any question, we can discuss your question or your understanding. If you feel any difficulties, if you could not understand any point, we should discuss. Then it will be easy if we go for to solve the next equation, next problem. Do you have any question, please? Please ask. Do you have any question? We have only 117 students, but we're supposed to have 163. Any question? Are you here?
No question.
So no question. No question means there is a probability of two things. First one is you are understanding everything clearly, and second possibility is you could not understand anything. So from which group you are? You are understanding everything, or you could not understand anything? How can I understand? So where is my shares? Oh, oh, oh. So again, if you would like to practice this problem also, how Gauss elimination method is going on, how to apply this question, this technique to solve the problem. So you can again check. This is the argument matrix. We can very easily write this matrix form. Then our target is to make this 0, 0. So how can we do this? This is one system, one rule to do this. You can do other things also. What they did, R2 minus 2 R1. So we have 2 here. So R2 minus 2 R1, that means 2 into 1. 2 R1, then it will be 0 very easily. At the same time, for 3, R3 minus 9 R1. We have 9, so 9 R1. So we get first 2, that means if we say this is A, 2, 1, 8, both become 0. So now our target is to make this term 0. If this is, then again we can do R3 minus 4 R2. So here, if you do this, then you will get this equation. So now rank A equal to 2, the rank AB equal to 3. Therefore, the system is inconsistent and has no solution. That means this equation, you cannot solve this problem as like linear equation. If you find such type of problem, then you should write, no, this is not exact equation that could not be solved by Gauss elimination method. If you go for
এখানে র্যাঙ্ক আর এখানে র্যাঙ্ক এ বি ইকুয়াল টু 3 কি রকম হলো? এখানে র্যাঙ্ক এ বি ইকুয়াল টু 3 এটা কি রকম হলো? ইকুয়েশন
A matrix A, if you multiply this with B, then you say 3 rank. Because here you can say here one row is no meaning. If you multiply with B, then rank is going to high, but the system is invalid system, we can say.
র্যাঙ্কটা বেড়ে যাবেন তখন কি রকম? বি তে যদি গুণ করি তাহলে তো নিচেরটা সব জিরোই থাকতেছে।
Oh yes, both are 0, but for this specific problem, if apparently it's showing that rank is 3, but system is inconsistent and unsoluble. That means we can say our target equation is not correct. That is why if apparently it is saying rank is 3, but it cannot be, still it cannot be solved. This is the conclusion here. Still is showing the rank is 3, but it's not, it cannot be solved by this system. That means our raw equation is not correct. So I am not going to solve many equation. The system is same for all case. I would recommend you to solve some problem from any book, anywhere. Most probably we will use current equation to solve such type of problem. Like at the starting of this class, I showed some equation. You already studied from DC circuit or AC circuit. If you go through the book, Alexander Sadiq book, you will get many equations like linear equations for solving DC circuits or AC circuits. So it's very important for electrical engineering mostly we need to solve electrical circuits, such type of linear equation. So with Gauss elimination method, we can solve this problem. This is our, if we say this is outcome-based study, that means our target is to solve some electrical problems which will be linear, then we can apply this. Again, still we can solve this problem by using our calculator. But if we don't want to use, or if we are not allowed to use calculator, how can we solve this problem using Gauss elimination method? So this is our target from this class. So again, for Gauss elimination method, if you have any question, you can check any book or any source from internet. Everywhere is available here, this process, Gauss elimination method. So please check and practice minimum on problem from your own side if you understand this class. So again, if you have any question before going to finish this class, if you have any question, then we can discuss. Otherwise, we should.
Sir,
Please.
sir, please can you share with us the PDF of the notes that you have used today?
Could you please again?
Sir, I'm saying please, can you share with us the PDF of the lecture notes
Oh,
that you have used tonight?
I'll send to Sierra and they will distribute you. Of course, I'll send
Yes, sir.
class,
Thank you.
previous class and today's class PDF. I'll send.
So please give the recording also.
Okay, so you need this. Okay, I'll give. So any question? If not, then I should record your attendance today. What do you think? Please help me by your response so that I can record your attendance. So from section C, we are starting.